All right, today we're going to cover 11.3, which is solving equations using quadratic methods. And I just want to review the methods we have to solve quadratic equations. So our first method that we learned in 11.1 was to complete the square and use the square root property. In 11.2, we learned about using the quadratic formula after we've made sure that our equation is in standard form. And then something we should already know how to do, but maybe we haven't reviewed for a while, is to factor the quadratic as two distinct factors and then use the zero factor property. So remember, the zero factor property tells us that a product of factors equals zero if and only if one or more of the factors is zero. So if A times B equals zero, we know that either A or B has to be zero, and it's possible that both are zero. So completing the square and using the square root property works for every quadratic. We can do that with any quadratic. Using the quadratic formula also works for every quadratic. But really, both of these techniques can be somewhat cumbersome. So factoring is usually the first place you want to go to try to solve a quadratic equation. The problem is it's not always possible to factor a quadratic. Okay, so today we're going to go over just when to use these different methods. And just to review a little bit of factoring, let's do this example here. If we've got x squared minus 13x plus 36 equals 0, we want to look at it and say, this is not a good candidate for completing the square. We could plug it into the quadratic formula. That'd take a little bit of work. First check, can we factor it? And indeed we can, right? We want to come up with two numbers that are going to multiply to positive 36 and add to the negative 13. Those two numbers are negative 9 and negative 4. So this guy will factor as x minus 9 times x minus 4. Make sure when you do this, before you try to factor, you want to make sure it's set equal to 0, right? You need to be in standard form before you try to factor. Now that we know it's set equal to 0, this factor times this factor equals 0. We use the zero factor property. So we know that either x minus 9 equals 0 or x minus 4 equals 0, possibly both. Then we can solve these individual linear equations that tell us either x is 4 or x is 9. One of those two things has to be the case in order for this equation to be true. All right, so that's factoring. And really, if you can do that, that's the easiest thing to do. But you can't always factor, and that's why we have the quadratic formula. And occasionally the square root property is also very easy if we are in a non-standard form quadratic. If you have trouble doing this factoring and you're not sure how I did that, review the factoring video in the week 1 module. You really need to know how to factor these guys, okay? So how do we know what to do? Should we complete the square and use the square root property? Should we use the quadratic formula, or should we factor? So here's a little guide. If the equation is in the form of something squared equals a constant term, use the square root property, right? The square is already completed for us, so bam, we can go straight into the square root property, okay? But if it's not already completed for us, completing the square takes a good bit of work, and so it's better to use one of the other two techniques. So if we're not in this form, go to step 2. Write your equation in standard form. Every other technique besides the completing the square root property, every other technique requires our equation to be set equal to 0 and in standard form. So if we're not going to use a square root property, make sure you get your equation in standard form. Once you're in standard form, try to solve by factoring, right? If you can see the two factors, if you can factor this guy, that's going to be the shortest way to your answer. If you can't factor it, either because it's not possible to factor, or your just brain isn't working and can't, figure out the factors, which is fine, then go on to step 4, being use the quadratic. The quadratic formula will always work. It's just a little more cumbersome than solving by factoring, and there's chances you can make some mistakes with negative numbers there. Okay, that's why you want to solve by factoring if possible. If not, quadratic formula will always work. So these are the steps you want to use anytime you are trying to solve a quadratic equation. Make sure you are a master of all 3 techniques, because at any given time, you're going to need each of those 3. And if you know which one to use, it will save you a lot of headaches. Okay. So I have some examples for us that aren't immediately quadratic equations. In fact, these are radical equations, rational equations, and some higher degree equations. But in all of these equations here, I have 5 that I'm going to work through. We're going to end up using quadratic methods. And so I'm going to give you an example of each of these types, and I'm going to work through it on my whiteboard. So our first example, x minus the square root of x plus 1 minus 5 equals 0. This is a radical equation because we have that square root in there. And remember, solving radical equations involves isolating the radical and then raising both sides to the power of the index. In other words, we need to get that square root on one side and then square both sides. So I'm going to move that square root to the right by adding square root of x plus 1 to both sides. And if you're wondering why I'm moving it to the right versus moving the other stuff to the right, it's because it's nice to have all positive terms, and we don't have to worry about messing with negative numbers. So we're going to have x minus 5 equals the square root of x plus 1. We square both sides. And we end up with x squared minus 10x plus 25. And if you're wondering how I did that so quickly, it's because, remember when we were completing the square, when you have a binomial like this, or when you have a quadratic like this thing divided by 2 squared, right? This is that perfect square that folds up to the factor being this coefficient divided by 2, okay? So want to get comfortable just kind of noticing that pattern. It's okay if you have to multiply it out, that's fine. And then on the right-hand side, we've just got our x plus 1. Keep in mind what we just did here. We squared a square root, and so we are introducing possible false solutions, okay? Now, if we want to go to solving this guy, we're going to ask ourselves, gosh, is this in a perfect square form where we can square root it? No, not at all. So we're going to set it equal to 0 by moving our terms over. We're going to subtract x and subtract 1 from both sides. And now we've got x squared minus 11x plus 24 is equal to 0. Okay. And let's move that all over here. Now we're going to see if we can factor. So we want to find 2 numbers. We want them to multiply to 24 and add to negative 11. Okay, so if they need to multiply to a positive number, they both have to have the same sign. And if they need to add to a negative number, they're going to have to be negative. So we're going to look at 2 negative numbers. I think -8 and -3. So this thing factors to x minus 8 times x minus 3 is still equal to 0. And then using our zero factor property, we can say that either x minus 8 equals 0, in which case x will equal 8, or x minus 3 equals 0, in which case x will equal 3. Okay. But remember, we introduced a false solution when we squared a square root. So we need to check back in our original equation. So our original equation is x minus the square root of x plus 1 minus 5 equals 0. Let's plug in our 8 for our x. And now we get 8 minus the square root of 9 minus 5 equals 0, which is 8 minus 3 minus 5 equals 0, and that is true. All right, so we know that 8 indeed is one of our solutions. 8 works. Okay, we checked it in our original equation. It works. Let's try plugging in the 3 instead of the 8. And I'm just going to erase this stuff. So we've got 3 minus the square root of 4 minus 5. Does that equal 0? Well, that's 3 minus 2 minus 5. That actually equals -4. So no, -4 does not equal 0. So that is not a solution. Right? So we just solved this radical equation using quadratic methods, because at this certain point in our radical equation, right here exactly, it became a quadratic equation. So we had to employ our quadratic methods. We saw that we could not complete the square very easily, so we set it equal to 0 and tried to factor, which was successful. And then because we had a radical equation where we squared a square root, we made sure to check our two answers to realize that one of those answers was not correct. Okay. Let's go on to the next example, which is a little more interesting. Here we've got x to the 4th minus 7x squared minus 144 equals 0. Okay. So notice this is a 4th degree equation, not a quadratic equation. What we're going to do in this is a special technique called substitution. We're going to do this substitution to make this a quadratic equation. We're going to let our x squareds, we're going to substitute that with a y. Okay, so what that means is, see this x to the 4th, that's really x squared squared. So x to the 4th is going to become y squared. All right. And this x squared is going to just become a y. All right. And that's because we did this substitution. The trick in substitution is to remember that we are still trying to solve for x, right? Y is just something we made up to replace our x squared. But in the end, we need to figure out what x is. Okay. We've got a quadratic, it's in standard form. Let's try to factor. So we need two numbers. They need to multiply to 144, or negative 144, they need to add to -7. So if they need to multiply to a negative number, they have to have different signs. And if they're going to add to a negative number and they have different signs, then the negative number needs to be the larger magnitude. Okay. So in this case, a -16 and a +9 will multiply to -144 and add to -7. So that tells us that either x minus 16 equals 0, or x plus 9 equals 0 using our 0 factor property. Okay. Oh, excuse me. I've already made some mistakes here. We are not dealing with x's, we are dealing with y's. That's why I put it in red. Okay. So y minus 16 equals 0 or y plus 9 equals 0. So if y minus 16 equals 0, that means that y equals 16. And if y plus 9 equals 0, then y equals -9. So we've got these two values for y, but we don't want y, we want x. And we know that x squared equals y. So we've got that y equals 16 and that x squared equals y. So we know that x squared equals 16. And we can use the square root property here to give us that x equals plus or minus the square root of 16, which is 4. We also know that y equals -9 and that y equals x squared. So x squared equals -9. So we can use the square root property here to tell us that x equals plus or minus 3i, right? The square root of -9 is 3i. So what do we have here? We have 4 solutions, right? We have 4 solutions. We have +4, -4, +3i, and -3i. It makes sense to have 4 solutions when we have a 4th degree equation. Okay. So here we used substitution to make a higher degree equation perform like a quadratic so that we could use the quadratic methods. The trick is to remember when we solve for our what we call a dummy variable, this y is our dummy variable. Once we solve for that, we have to make sure to go back and undo our substitution so we can get our actual variable x. Okay. So that is example 2. Let's take a look at, let's do one more substitution while we're here on the substitution methods. So definitely this guy, just notice that pattern. We had something to the 4th, something squared, and a constant term. So it's very easy to substitute in that our x squared is our dummy variable. Here's one that's just a little bit harder to see. We've got x to the 2/3 power minus 2x to the 1/3 power minus 8 equals 0. This is another substitution situation. If we replace our x to the 1/3 with the y, if we replace x to the 1/3 with a y, notice that this is really x to the 1/3 squared. So if x to the 1/3 is y, then this initial term becomes y squared. And this second term becomes -2y. All right, so here's another case of substitution. Now we have a quadratic. Let's try to factor it. We've got this guy will factor to y plus 2 and y minus 8. Or sorry, y plus 2 and y minus 4. So we got y plus 2 times y minus 4. So I'm just going to jump ahead a little bit, and that's going to tell us that y equals -2 or y equals +4. Okay. So we've got y equals -2, and then we've got y equals a +4. But remember, we want x, so we're going to substitute this x to the 1/3 in for y. So now we're going to say x to the 1/3 equals -2, or x to the 1/3 equals 4. And we want to get x by itself, so we're going to have to cube these guys. And I'm doing both equations at the same time. You can do them separately, of course. So then we're going to get that x equals -2 cubed is going to be -8. And x equals 4 cubed. Let's see, that's 6. 4 times 4 is 16. And 16 times 4 is 64. Okay. So we've got these two solutions here. See. X is -8 and x is 64. It's always a good idea to go back and check your answers, but I'll leave that up to you. Okay, so those are two places where you might use substitution, and some are a little easier to see than others. I've got two more examples, so bear with me. If you guys are having trouble following this far, maybe pause here and re-watch the examples that you just saw before moving on to the next examples. Right. Our next example is going to be a rational equation. Remember, that's where we have the fractions. So we've got 6 over x squared equals 3 over x plus 1. Anytime you want to solve a rational equation, it's a good idea to start out by multiplying by the LCD of all your denominators, right? So that we can get rid of fractions. So in this case, our LCD is x squared times x plus 1. Okay, so we're basically multiplying both sides of our equation by all the denominators so that we can get rid of them. So I'm going to multiply this guy by x squared times x plus 1. And I'm going to multiply this guy by the x squared times x plus 1. Now, this denominator will cancel out with that factor of x plus 1. This denominator will cancel out with that factor of x squared. So we're going to end up with a x plus 1 times 6 equals 3 x squared. Okay. Once we recognize that we are going to have a quadratic, it's a good idea to, I guess, first check, can we use the square root property here easily? No, we can't. So we are going to distribute everything out and set it equal to 0. So we've got on the left-hand side, we've got 6x plus 6. And then I'm going to subtract 3x squared from both sides so that we end up with, -3x squared plus 6x plus 6 equals 0. Okay. Now we can ask ourselves, should we try to factor this or should we try to use the quadratic formula? I am going to try to factor it, even though we have that -3 in front, which is kind of messy. But first, I'll do a little factoring ahead of time. I see that each term has a factor of 3 in it, and I don't like having a negative sign in front. So I'm going to factor out a -3. And actually, instead of factoring out a -3, I'm going to put everything on the other side. So that will change its sign. All right. That way I've got a positive coefficient in front And then I'm going to factor out that 3 from here. Okay. That's just a little easier polynomial to deal with. So we've got x squared minus 2x minus 2. And in fact, if we want to divide both sides by 3, we could, and that 3 will just disappear. Okay. So now let's try to factor this to get into a position to use our zero factor property. We need two numbers. They need to multiply to -2 and add to -2. Those two numbers don't exist. So in this situation, we can't factor. So we're going to use the quadratic formula. All right. We can't factor, so we're going to use the quadratic formula. And if you plug everything into the quadratic formula, we're going to get that x equals 1 plus or minus the square root of 3. Okay. All right, I'll let you guys do that on your own. So we get 1 plus or minus the square root of 3. And then finally, we have to remember that we started off with a rational equation, which means it's possible that one of these values could cause our denominator to equal 0. And if it makes the denominator 0, we're in trouble and it's not actually a solution. So you just want to check back. Okay, if 1 plus root 3 is this denominator, no, 1 plus root 3 squared is not 0. What about 1 minus root 3? Would that be 0 when squared? No. Is 1 plus root 3, if we add 1 to that? Nope. 1 minus root 3, if we add 1 to that? Nope. So we just do a quick check to make sure that none of these solutions are going to cause your denominators to be 0. And then we are good. All right, so that's how we solve a rational equation using quadratic methods, because we had to use that quadratic formula there. All right. And now our final example. So this last example is a little bit different. And here we are solving for y. It's just a different variable that I decided to use for no particular reason, literally no particular reason. Just because the textbook has it as a y in one of the sample problems. Okay, so we have this equation. It's a third degree equation, right? It's not a quadratic. It's a third degree. We've got a 3 term, a 2 term, a 1 term, and a constant term. We can solve this equation by factoring. And so that's just another thing you want to look for when you have these higher degree equations. Try to pair up two terms that share common factors. So here, both of these terms contain a y. Both of these terms contain a factor of -3. And we're going to just factor them and see what happens. A lot of times when you factor, you get nowhere. But if you're using a question from the text in a section where they want you to learn how to factor, they might give you something that pairs quite nicely and will factor for you. So I'm going to factor out a -3 from this second pair of terms. And when I take a -3 out of 75, I end up with a 25. Okay. Well, isn't that convenient how I factored? Now I have two terms, this term minus this term, and both of these terms have a factor of y squared plus 25. So I can factor one more time. So this is called factoring by grouping. We pull out the y squared plus 25 because that's the common factor to both our terms. And what remains is the y and the -3. And we still equal 0. So here is where we're going to use our zero factor property. Either y squared plus 25 equals 0 or y minus 3 equals 0. If our y minus 3 equals 0, that means that y equals 3. So that is one possible solution, that y equals 3. The other possible solution is that y squared plus 25 equals 0. This is going to take just a little bit more work. We'll subtract 25 from both sides so that we get y squared equals negative 25. And then we are going to have to use the square root property. And remember, when you do that, you add in that plus or minus. So this is going to give us that y equals plus or minus 5i, right? Because the square root of negative 25 is 5i. So we've got 3 solutions here. Positive 5i, negative 5i, and 3. We've got 3 solutions to a third degree equation, right? So that's the last example. That's factoring by, or sorry, that's solving by grouping. And that's when you have, 4 terms that you cannot combine in any other way. Find a way to group them so that you can factor out the same thing and then factor again. All right, that is 11.2. Good luck. And please, please, please review the factoring, factoring quadratics in general if any of that is not totally fresh in your mind. Okay, good luck.